Hello everyone, welcome back to the CCNA training. And yesterday we discussed about, in the last class, we discussed about EIGRP. So EIGRP first of all stands for Enhanced Interior Gateway Routing Protocol. And we learned what are the basic characteristics of EIGRP. So let's quickly have a, a lab. And before that, let me help you remind all the points which we discussed in the last class. So we'll be using packet tracer. In the last session, we discussed about some characteristics of EIGRP, and the very first thing which we discussed about was that EIGRP is an open standard protocol. But after 2013, then after this, we discussed that EIGRP is also known as Advanced Distance Vector Protocol. Also, this is a classless routing protocol, which means that subnetting and VLSM are supported with EIGRP. So this is a classless routing protocol, and the AD value, the administrative distance value of EIGRP is 90. So we discussed about 2 points, which were that it uses dual and it supports equal and unequal load balancing. So we discussed about all other characteristics except these two, and we will be looking into them today only. But before that, let's quickly revise the configurations of EIGRP with another practical. And today we are going to take 4 routers with different networks. So this will help you to brush up the EIGRP, and after that we'll be able to move ahead with other routing protocol, which is OSPF. So here we have the packet tracer, and okay, so let's quickly create a topology with 4 routers. And let's name this router 1. Similarly, router 2, 3, and router 4. We will quickly add some end devices. Now let's connect them together using the cables. So this is how a topology is going to look like. And we are going to consider the routers on different locations. And let's try to join these locations together to make communication between these possible. We will have to add some modules to the router to make them connected together. We are doing this to increase the number of ports and make connections possible. So now if you try to connect them together, that will work. Now let's consider all of these routers in different states, and let's consider them being branches of an organization, and let's try connecting them together. So let's say the R1 runs a network of 150.10.10.1, 10.1, and here we have 150.20.10.1. Similarly, on router number 3, we are going to take 150.30.10.1. Now between these two routers, we are going to take an IP range from class C. So let's take 192.168.10.0, and here we are going to take 30.0. So this is our topology, and now we'll be configuring EIGRP between these routers to make communication between these PCs with these, or these. So basically we are going to try making communication between devices from different networks possible using EIGRP. So first of all, let's get into the CLI of router number 1. I hope you guys are able to see the okay. So I hope that is visible to you all. And first of all, let's quickly enable the router and get into the configuration mode and rename it as R1. Now, the first step is configuring IP addresses on interfaces. We'll go to interface FA 0/1 and configure the IP address 192.168.10.1. With that, add the subnet mask and run the command no shutdown to make the port up. Similarly, we will configure the IP on Ethernet 1/0 and IP will be 192.168.20.1. Add the subnet mask and no shutdown. Now we have another network on FA00. So we'll go to interface FA00 and assign it the IP address 150.10.10.1. Now let's quickly get to the CLI of router number 2 and assign the IP addresses. This FA00, we have IP address 150.20.10.1 at the default subnet mask. Now this FA01, we will assign a IP address 192.168.20.2 since we gave 20.1 on router number 1. We'll go to interface Ethernet 1/0 and assign it IP address 192.168.30.1. And with that, we are done with the configuration of router number 3 for the IP addresses. Now let's quickly assign IP address to on router number 4 as well, so that we can move ahead towards the configuration of EIGRP. So this FA00, assign the IP address 150.40.10.1, add the subnet mask and no shutdown. Similarly, on interface FA0/1, IP address 192.168.10.2, /0, IP address 192.168.40.2. Now we are going to configure DHCP pools on each of the routers so that we can assign IP address to the PCs using DHCP. We will take an exit from the interface mode and create a DHCP pool for network 150.10.0.0. Okay, we have to add the subnet mask with it. Now the default router IP will be 150.10.10.1. And on router number 2, IP pool which will be used is 150.20.0.0 at the subnet mask, then default router IP, so that was the configuration for DHCP pool on each of the routers. Now we will try assigning the IP address to PCs using DHCP. So let's see if that's working or not. We will go to desktop IP configuration and select DHCP, and we get the IP address. So let's quickly get IP for all of the PCs in the topology, and after that we will look into the configuration of EIGRP. Now, as we discussed in the previous class, to make the communication possible between devices, all you have to do is you just have to advertise your directly connected routes to the rest of the devices in the topology. So we'll go to router number 1 and we will see what all directly connected routes are there on router number 1. So for that, we have a command do show IP route. And when you run that command, you get the list of directly connected routes. So we have 10.0, we have 192.168.10.0. Then we have 192.168.20.0. We will configure router EIGRP, and after that you have to assign a autonomous system number. So for that you can even add a question mark, and you will see that within the range of 1 to 65,535 you can choose any number for your EIGRP system. So we are going to take 100, and after this all you have to do is type network and advertise your directly connected routes. So first we'll take 150.10.0.0. Okay. Then after this, have 192.168.10.0, and at last we have 20.0. So these were the directly connected routes to router number 1. Now we will go to router number 2. So here we have 150.20.0.0. Then we have 192.168.20.0 and 192.168.30.0. So as we press enter, we see a log which says IPIGRP 100 neighbor 192.168.20.1. So once I advertised about 20.0, EIGRP enabled router 2 to discover R1 as a neighbor. So since both of the routers are in same network, they became neighbor. Now we will move ahead and will advertise about 30.0. So we have another route with us, network 192.168.30.0. Now when we look at the routing table of router number 3, we can see there are three routes which are 150.30.0.0, then 192.168.30.0, then 192.168.40.0. We'll go to router EIGRP 100 and we'll advertise about our directly connected routes. Now we are left with the configuration of router 4, and devices are able to communicate with each other or not. So we have 40.0.0, then we have 192.168.10.0, and at last 192.168.40.0. We say router EIGRP network 150.40.0.0, then network 192.168.10.0, and the last one 192.168.40.0. Now, if we take a look at router number 1's routing table, we'll be able to find all of the routes which are there in the topology. So we will run the command do show IP route, and here we get the list of our routes. So first of all, we have 10.0, which is directly connected, and if we see at the tag C, so it says connected. So the route 150.10.0.0 is the directly connected one. Then we have 150.20.0.0 with a tag of D, and D stands for EIGRP. So this route has been installed with the help of EIGRP. Then after this we have 30.0.0, then 40.0.0, then we have 192.168.10.0 and 20.0. After that 30.0 and 40.0. So if you take a look at the topology, you will be able to identify that all of the routes which are there on the network are now in the routing table of R1. Now let's quickly try making communication between devices. And if we try pinging from PC0 to let's say PC5, so first packet might get dropped, and once you try it again, it says successful. So communication is being successful between devices. So that means EIGRP was successfully configured, and now this was practical between two classes as well. Here we used a network from class C, and on individual routers we use a network from class B. So that was the practical of EIGRP, and now you can take your time to try this on your end and let me know once you are done. So I hope everyone is done with the practical and we are good to move ahead. We have some questions on the chat. Yes, Shubham, you can use /30 and that will work since EIGRP supports subnetting. Okay. No, you cannot change the default AD values of protocols. So first of all, AD values are not for routes. These are for protocols. Okay, so now let's understand something about dual terminology on which EIGRP works. So let's quickly okay, so just a minute more. Let me quickly show you the commands. Okay, so we have a question how to check the interface IP address. So you have to just get to the enable mode and type show you have to type show IP interface brief. Once you press enter, you will be able to see which interface is configured with what IP address. So we can see that fast Ethernet 00 is configured with 40.10.1, and similarly we have all the details for them. Also you can see that whether they are up or down, so you get some basic details about them. Now we are going to understand something about dual terminology, and here we go. So sub interfaces are somewhat similar to interfaces only. So that's something you create for an interface. So let's say you have FA00. So you can create a sub interface FA0 dot something which you like, and you can use them as an interface just like you use the other interface for your configurations. Now let's quickly get to dual terminology and understand what it is all about. So we have dual. So this is something which is used by EIGRP for the basic for the functioning of EIGRP. So dual stands for diffusing update algorithm, and I want you guys to be a little focused because this is something you might find tricky a little bit, not very much, but yes, you have to be focused while I'm telling you about this. So let's say we have a router number 1, and this is the source router, and with that we have another router, let's say router number 5. So now router number 1 has 3 different routes to reach router number 5. Let's say the first one is via router number 2, then we have another one via router number 3, then router number 4. Okay, so before getting to dual terminology, let me first tell you about the metric used by EIGRP, which I just remembered that we left for today. So we discussed about something known as K values. Now let's first understand this. Then after that, we'll be able to understand dual terminology more accurately. So we have some K values for EIGRP, which are used as EIGRP metric. Now we have 5 different values. We have K1, K2, K3, K4, and K5. Then the K1 is supposed to be there for bandwidth. Then we have K2 as load, K3 for delay, K4 for MTU, which is maximum transmission unit. Then we have K5 for reliability. Now, by default, the values for these K values are set to be 1 for bandwidth and 0 for load. Similarly, delay is 1. Then we have MTU as 0 and as 0. So this doesn't mean that bandwidth will always be 1. However, it means that let's say you have a bandwidth of 100 Mbps, so it will be considered as 100 into 1. So this is something which 1 and 0 denotes. Then after this, we have a formula to understand the metric of EIGRP, so in which these K values are being used. So okay, now the formula looks like, oh, let me just erase all of this. I'll write it again if you want, but for that let's make space for the formula. We make some calculations for calculating the metric of EIGRP, and the formula of metric look like the K1 multiplied by bandwidth, then we have, okay, let's keep them in bracket. Then we have K2 multiplied by bandwidth and divided by 256 multiplied by load. Now after this, you have to add K3 multiplied by delay and whole of this gets multiplied by 256. Now I want you guys to understand something that we learned just now, that K2 is considered as 0, right? So if we multiply something with 0, so the whole of it, the result of this will become 0, right? And even if you divide something, even if you try dividing 0 with something, the result will always be 0, right? So the whole, this part becomes 0. Then after that, we are left with K1 multiplied by bandwidth and plus 0 plus K3 multiplied by delay, and the whole formula gets multiplied by 256. Now, if we consider K1 and K3 as the values which we have learnt about, then it will become 1. So we are left with bandwidth plus delay multiplied by 256. Make sense? So if you have a link between, let's say, router number 1 and you have another router here, then we have router number 3 here. So let's say the link is of 512 kbps and the delay is 2000 milliseconds. Then after that we again have 512 kbps link and 2000 milliseconds of delay. So bandwidth will be considered as 512,000. So you just convert them into bits, and with that delay, when it comes to delay, you have to add up all the delays which are there between links. So delay will be 4,000, right? And when you multiply them with 256, you get the metric of EIGRP. Now, I remember someone asking a question which was about a value in the route of EIGRP. So let's quickly get back to the topology and go to the routing table of R1. If we go to show IP, so the value you see after 90 is AD value, and the value you see after the slash is the metric of route. So in case of rep, you see the number of hop counts, which is the metric of rep when it comes to EIGRP. So this is the calculation to find this out. Do you guys understand how the metric works for EIGRP? Now there's one more thing to keep in mind. Let's say you have the links with different speeds. So let's say the R1 is connected to R2 over a link of 128 kbps. And similarly, R2 is connected to R3 over 64 kbps. Now, the thing to keep in mind always is you have to always use the bandwidth which is least on the network. So here the 64 kbps will be used, and instead of 512,000, we'll be using 64,000. Okay, I'm repeating myself again, don't worry. So till now, I hope you guys are clear that the least bandwidth will be used while calculating the metric, and I hope you guys are also clear about the K values. Let me know if that's right, and we shall move ahead with the formula. Otherwise, I'll talk about K values again. And are you guys like clear about K values and why we are using 64,000 here instead of 128? No, that's not a part of CCNA. EIGRP is not a part of CCNA. So even if you guys are like not very much clear about this, so that's not a very big issue. But however, since we are doing this in the class, I want you guys to be able to understand this. Okay, so let's quickly have a look at the formula again. And before that, I'm quickly writing the values here. So we have K1 as 1, then we have K2 0, K3 as 1, K4 0, K5 0. Now the metric of EIGRP can be calculated using a formula. So okay, so this clear is for K values, right? And now we have the formula for calculating the metric. So the formula looks like K1 multiplied by bandwidth plus K2 multiplied by bandwidth, and this part is also divided by 256 into load. Then after that we have K3 multiplied by delay, and the whole formula gets multiplied by 256. This is the formula to calculate the metric of EIGRP. So metric is nothing but cost which is used between routes, and this is something used by EIGRP to select the best route, right? Then after this we know that K2 is 0, right? If we talk about the default representation of K values, we have 1 0 1 0 0. When it comes to K2, it is 0. So if you multiply bandwidth with 0, you get 0, and if you divide 0 with something, so that's also 0, and this whole part results into 0, right? Clear till now? Okay, great. So now we are left with K1 multiplied by bandwidth plus 0 for this part, then K3 multiplied by delay, and the whole of this formula gets multiplied by 256. Now considering the value of K1 and K3 as 1, we get bandwidth plus delay multiplied by 256. Is it clear till now? So delay, when it comes to delay, you have to take the sum of delays between links. So let's say there's a router 1 connected to router 2, then the router 2 is again connected to another router 3, and the delay between them is 2000 milliseconds for this, then again 2000 for this. So the value for delay will be used as 4000. You have to take the sum of these delays between links, and when it comes to bandwidth, you have to choose the lowest bandwidth over links. So let's say here we have 64 kbps and here we have 128 kbps. So we know that 64 is less than 128, so I'll be using 64 in the calculation of metric. I hope you guys understand this now. And so this was all about metric calculation of EIGRP. Now we'll move ahead towards understanding the dual. So that's diffusion update algorithm. Okay, so let me write what they represent. Okay, so you guys can keep a note about the 1-0 part of these key values, and again I'm repeating myself. So that's not something which determines the bandwidth when it comes to, let's say if we talk about the 1 of K1, so that's not something which determines the bandwidth, but instead if we have a bandwidth of 100 Mbps, so this will be something like 100 multiplied by 1. So this 1 is we are talking about. So this 1 is something which is K1, and K1 is for bandwidth. Then we have K2 for load. Then we have delay and MTU. Then at last we have reliability. So that's not something for CCNA. However, we have just took a look about how metric works for EIGRP. Now we are going to understand about dual, which is again a part of EIGRP only. And today we'll be winding up EIGRP. Now, as we discussed about the metric of EIGRP, we are pretty sure that if a router is connected over different links to the destination router, so the router will choose the best route on the basis of metric calculation, right? So as we discussed about RIP, when it comes to RIP selects the best route uh, using hop count as the metric. Now, as we discussed about the metric of EIGRP, we have some basic introduction about how EIGRP chooses the best route. Now, let's suppose this is route 1 and this is router 5. This is router 2, similarly router 3, and we have here router 4. Abhijit, please mention what do you want me to repeat, and I'll repeat that for you before moving ahead. So I'll make this a little quick so that other people don't have to wait. K values, okay. So I'm repeating myself. We have K1 for bandwidth, which is 1. I want you to keep a note of this now. So just a minute, guys. We have K1 as 1 and is there for bandwidth. Then we have K2 as 0 for load. Then we have K3 as 1 for delay. Then K4 as 0, which is there for MTU, which is maximum transmission unit. Then we have K5, again 1, which is, oh, I'm sorry, 0 again, which is there for reliability. So this was just for an introduction towards the metric of EIGRP. Now we are going to discuss about dual terminology. So let's say the metric between R1 and R2 is 20, and R2 and R5 have a metric of 20. However, when it comes to EIGRP R2 metric, when it comes to EIGRP metric, it is usually a big number. So for our understanding, we are taking it as 20 and 20. And let's say the metric between these two routers is 25. Then again 25. And at last, R1 and R4 has the metric of 30. And we have 50 here. Now, if we talk about the candidates which are there in the topology, we can see the first route is R1 being connected to R2, then reaching R5, right? Clear till now? Then after that we have another route which is R1 getting connected to R3, and at last reaching R5. Then R1, R4, R5. These are the possible routes to reach R5 from R1. Now we have something known as feasibility distance and advertised distance, which help us to determine the best route for EIGRP. So we have feasibility distance and we have AD, which is advertised distance. So this is not the administrative distance value, that's something different. This we are talking about dual, and under dual we have these two distance. So the first one we have is feasibility distance. Then we have advertised distance. Advertised distance is also known as reported distance. So also known as reported distance. Good. Okay. Now let's understand what feasibility distance is. So feasibility distance is total cost from source to destination. So cost is nothing but the metric value which we are which we have assumed as 20. So I want you guys to answer this. So for the first route, the feasibility distance, what will be the feasibility distance? I'm repeating that feasibility distance is total metric value, or you can say the total cost from source to destination. So when it comes to R1 to R2, then after that from R2 to R5, what will be the feasibility distance? 40, right? So we have the answer 40. So let's write 40 here, right? Yes. Okay. So now when it comes to route number 2, which is from R1 to R3, then after that from R3 to R5, the feasibility distance or FD will be 25 plus 25, 50. And similarly, for the third route, the feasibility distance will be 80. So let me write this neatly so that it doesn't make any confusion. So this is 30. This is 50. Okay. So I hope till now we are clear. Now, if we talk about advertised distance, or the other name for which is reported distance, so that's something, the value of, so this is the total cost from next hop to the destination. So if we look at the route number 1, so if we talk about AD, so the value should be total cost from next hop. So if we look at the next hop of route 1 for router number 1, so it's going to be router number 2, right? Next hop is R2. So the total cost from next hop to destination. So what's that? We have 20. Make sense? So AD is nothing but the total cost from next hop to the destination. So if you look at the next hop of R1, so that's R2. And if you look at the cost between R2 and the destination, which is R5, so it's 20, right? So AD is going to be 20 for the first route. Similarly, 25 for the second one, and 50 for the last one. Make sense? Do you guys understand this? Now we'll look at the reason behind finding these FD and AD values. Now again, we have two terms which are successor and feasible successor. So when it comes to successor, it is basically the best route available from source to destination. And so basically this is the route which we install in the routing table. As we discussed yesterday, we create three different tables. The first one we have neighbor table, then we have topology table, then we have routing table at last. So this is the best route which is installed in the routing table and is basically used to make transmission of data possible. So after that we have feasible successor. So this is the next best route. After successor. Make sense? So we have successor as the best route, then we have feasible successor as the next best route. So this route act as a backup route, and in case the successor or the best route goes down, instantly the feasible successor route, or we can say the backup route, gets installed into the routing table and um, acts as a route for the data transmission. Do you guys understand? Okay. So now these feasibility distance and the advertised distance, these values are used to consider the successor and feasible successor for routing table. So the lowest one is considered as the successor, as it is going to be the best route, right? So the route with the lowest metric, which is the cost for the data transmission, is considered as successor. Then after that, the next best route, which is this route number 2, will be considered as feasible successor. Do you guys understand how feasible and successor routes are decided among different multiple routes? Now, when it comes to this successor and feasible successor thing, there's something known as feasibility condition, which has to be met in order to become the backup route. So condition is something which says that a route can be can only be feasible successor if RD of that route is less than FD of a route which is currently successor. So what does the condition says? It says that a route can only be feasible successor if the RD, which is the reported distance of that route, is less than FD, which is the feasible distance of route which is currently successor. So yes, the least values are to be considered as a successor. So the best route is usually the values with the least, you don't have to add them. So I hope the condition is clear to you guys. So if we take the example again and look at the FD and RD table which we just created before this. So we had something looking like, let's take an example here, and let's say the FD of a route is 40 and RD is 20. Then we have another route as let's take 30 and 15. So this route is going to be successor, right? I want you guys to check whether the other route, which is this route, meets the condition of being feasible successor or not. The condition says that it can only be a feasible successor if the RD of that route, which means if the RD of this route is less than FD of current successor route, so which is true, right? 20 is less than 30. So the condition is being satisfied, and RD value of this route is less than the FD value of the current route. So yes, it meets the condition and can be considered as feasible successor. You guys understand? Great. So this was something about the terminology, which is dual, on the basis of which AIGRP works. Now we will understand. Okay, so when we discussed about the k values, so you can manipulate these k values to make changes uh, in the speed, or you can say in the process of data transmission, but that's not something we discuss under CCNA, and that's some advanced technology and some advanced understanding is required to do that. Okay, now let's take another example, and I want you guys to answer this time. We have a router R1, then we have another router. Okay, we have another router as R2, and let's take R5 as the destination router. So this is the first route. Then we have this. Then we have R4 getting connected to R5. So, okay. So the metric between R1 and R2, let's take them as 10 and 10, 10. Okay, this also 10. Let's take 15 here and 6 here. So we'll create the table of FD and AD, or we can say RD. Now, if we look at the candidates, if we look at the candidates we have, the first one goes from R1 to R2, then R5, then R1 to R3, reaching R5, and at last R1 to R4 and R5. So these are the available candidates which are there to reach the destination router. Then we have feasibility distance. Then we have RD. So I want you guys to answer this. What will be the FD for the route number 1? Let me know in the chat quickly. 20, right? So that's going to be 10 plus 10, which is the total cost from source to destination. Similarly, for router number 2, for the route number 2, we have 20 as FD, and for the third route, 15 plus 6, it's going to be 21.